Good evening, everyone. A warm welcome to our live webinar on machine learning program. We are excited to have such a passionate group of learners here today. Now, please get ready for an engaging session filled with valuable insights and practical knowledge. Without further ado, I'll now hand over to Saurabh, who will take it from here. Over to you, Saurabh.
Hi, thank you, Tanzia. Hi, everyone. I hope everyone is well and good. So, let me start with my introduction. Just a quick, I just need a feedback. Am I properly audible to you all? AIML engineer, and like in a corporate, I'm working as AIML engineer, and it's 5 years to me in this field. And so, I'll share whatever my insights that I have faced in machine learning field and deep learning. And as you all know, generative AI is a boom right now. So, how things are going with it. So, I'll share my insights too, and what kind of data set you will be expecting if you will be working in this field. So, yeah. So, let's start with like fundamentals of machine learning. Okay. So, what is a machine learning? So, machine learning, as you can like get a meaning out of the word machine learning is something that when a machine learn from the data, right? When you make a machine learn from the data, that's a machine learning. That's a simple layman language, right? You can define what machine learning is. So how do they learn from data, right? So you all have like a system, computer, right? So why machine learning so popular? Because like whatever you do normally, you give a command to a system, your computer, and it will like give a output to you, right? If you press enter, like it will perform some action to it. If you press space bar, it will generate a blank space to a text. If you don't provide any intervention, if you don't tell machine to do, and it keeps learning by itself and generate a response to it by looking at the data, by looking at the behavior of you, that is what machine has learned, right? That is what machine learning is. Simply just to make a machine learn, and without any human intervention, it is able to generate responses, right? So a basic example I'll give is, for example, you wake up in the morning, you wake up at 7 o'clock, you fresh yourself, you eat breakfast, then you go to the work, and after the work whatever your regular activities, and then you came back home. So that's a pattern, right? That's a whole cycle that you do Monday to Friday, and Saturday Sunday it's a weekend, you do some different things. So if you provide this data to a machine, so in what machine learning will do, it will like get the insights from your regular activities. Okay, let's say Shivam wake up at 7, then he like ate breakfast, then he went to the office, then he do this and this and that. And if we keep providing him the same data, at one point eventually it is going to learn your pattern, right? So understanding the pattern, insights, and whatever like features in your data is, that's how machine learns, right? So how they learn is basically by the patterns, by getting the insights from the data that you provided, right? So there will be terminologies in machine learning that you will be facing recurrently, like on a when you will be in this field. There is terminologies like model, features, target, training, predictions. So these are some of the terminologies that I have mentioned. So what are these basically? So model is nothing but when a system learned, like it is able to recognize the pattern from your data, that is a model. Like model is something that is able to generate response when you give an output to it based on the pattern that it has learned. Okay, it has recognized in your data. That's what model is. What are the features? Features is basically the data, right? Features is basically the data. For example, suppose you have to make a model learn the prediction of a salary of an employee, right? You want to create a model, so what it will do, it will basically predict what will be the salary of this particular person. So in order to predict that, what you will be requiring, you will be requiring the experience, right? You will be requiring the job profile, you will be requiring like his education, right? From which field he belongs to, all these things. So what all these things are, these are the features, right? So these features will be required by the model in order to generate a response like the salary. And the next terminology is target, right? So what target is, as I told you, salary. Salary is the target that we need to predict, right? So I hope everyone is getting the point. The next one is training. Training is something that is done on a model to make the model learn based on the data, right? Your end goal has to be to make your model recognize the pattern. So how it is going to recognize the pattern? By getting the data from the features, right? That part is done during training. You train your model on the data repeatedly, so it get better and better over the time. And prediction, as I said, in order, prediction is something that a model predict, right? And that prediction is basically the target, which is the salary, as I told you. So salary is the target and prediction is the value of that target, right? So as you can see, it is written label in brackets for the target part, right? So these are the basic terminologies. I hope everyone is getting right. If you have any question, please do let me know. I'll keep checking the chat box. Okay. Now moving on to first, like what kind of machine learning problems are, like you can't categorize every problem as a machine learning problem. So as I told you, what machine learning is making your model recognize the pattern from your data and generate a response by looking on these pattern, right? As simple as it is. And without any human intervention, the model should be able to do that. That's what machine learning is. So there are categories of problem that you provide to a machine. For example, as I told you, the salary problem, right? So you have to predict the salary of an employee based on their experience, job profile, right? From their education background and all other features that you have, right? So during training of a model, when you train a model, you also let the model know that this is my target variable. Like for example, as you can see here, uh, in this slide, you can see there are columns: user ID, gender, age, salary, and purchased, right? So here in this particular problem statement, we want to predict whether a particular user is going to purchase something or not, like some product or not. Okay. So he's a male, for example, for the very first record, you can see he's a male, his age is 19, his salary is 19,000. So what is the probability of him purchasing that particular product? Let's say product A, or any, suppose, let's say any product like cloth, maybe a t-shirt or pant. Like, okay, what will be the probability? So this is basically during training, we provide also the purchase values based on the past data, right? Suppose I went into a mall, I purchased something, my history, my transaction history is being recorded, right, by the system of the that system that has been established in a mall. So when I will do training, I'll gather all the past data, and based on that, I'll see how many people are buying my product. Like, are they are male, or their age is more than 20 years or 30 years. Like, I'll target my audience, right? And I'll make sure my model learn. So in supervised learning, during training, I also provide my target column, like male 19, 19,000, and I also give 0 to the model. Like, this is my target variable, and you should look the pattern into it, right? That is what supervised learning is. You also provide the target value to the model, right? Unsupervised is something you don't have the target column. You only know, let me move on to the other slides. I'll come back to the supervised problem. So in unsupervised, what happen is you don't have the target column. You don't know what your target column looks like. There are some techniques in unsupervised learning. So unsupervised learning, you don't know have the target column, right? Suppose you get the data, you have your customers, you have, like, you recorded their behavior of purchasing something, right? So you simply are collecting the data. You don't know, like, you don't have a target column that he has bought this something or not, that he has purchased this t-shirt or pant or not. You don't have that data. You just looking their behavior, like their ages, which section they are going to buy something, and based on that, you are driving some conclusion. Okay, so he goes to that section that he might buy for it, right? So unsupervised learning, what you do is you don't have the target column. You categorize data into some sort of clusters, right? That's what unsupervised learning is. So in machine learning, these are used for, like, in different domains. Let's say in healthcare, right? So in healthcare, machine learning can be used. For example, it will you give a model their, like, for example, their age, right? Your, like, BP, what is the blood pressure, what is, like, how old are you, right? All those things, like, medical values that you have been examined for a disease, and the model will predict whether you have the probability of having that disease or not, right? That is what machine learning is. You will give all the data, like your diabetes, your BP, your age, and all other medical terminologies that there are. And based on that, the model will make a assumption that you are going to have a particular disease or not, right? So that is what machine learning is. In finance, you can also use machine learning, for example, for stock prediction, right? So if a particular stock is at a particular value, let's say on day one, and then it went to day 2, then what will be the prediction of day 3? So for that use case also you can use machine learning. In e-commerce also, in e-commerce, like for example recommender system, right? So suppose, as you have seen, as most of you have used Netflix, Amazon, Flipkart, right? You buy something, you buy let's say you buy a speaker, like Bluetooth speaker, and on the very next day you are also browsing phone, then the model will know by looking your activity that you are more interested in electronic devices. So for the very next time the model is going to suggest you some electronic products, right? So that is what machine learning is. It is learning by looking at your activities, right? That is one kind of use case in e-commerce. Another use case you can say is autonomous system, right? Like self-driving cars. That was autonomous system is. Just by looking at symbols like the road, by detecting the person, it will make a decision. Okay, this is a person, I have to avoid the collision here, or I need to turn right or left. That is what another use case. So in different use cases are there, and I think nowadays machine learning is booming because of the generative AI, right? But the base is the machine learning. Everything goes from the machine learning, and then move on to deep learning part. What is deep learning? So think about it. Let's say machine learning handles data in terms of Excel sheets, right? Numbers like Excel sheets or CSV file or text file, whatever the kind of information you can be able to provide, right? Let me tell you a few other things. So machine learning is basically to recognize the pattern from a file like CSV, Excel, text, right? Deep learning, what deep learning is? Deep learning is mainly focused on images, videos, audios, right? That's where deep learning happens. And apart from that, so this is all basically you have a target variable. You have this all these algorithms revolve around target variable, right? For predicting whether you provide a model an image of a cat, and how good is a model in predicting that it is a cat, right? Is the my model is able to predicting that this image includes cat. That is deep learning. But if you have a data, for example, as I showed you of the salary part, right? As I showed you the salary part, that is a data that I have in Excel sheet. I'll use machine learning. That problem will be categorized in machine learning, and the problem related to images, audio, speeches, these are categorized into deep learning. Okay, so it is just the type of data you are dealing with. In both the cases the model is learning, but the method of learning things is different in machine learning and deep learning, right? So how ML model works is basically, let's say you are dealing a classification problem. Classification problem means your target variable is a classified value. Okay, let's say classified value is, let's say, as this example, as I have told you before, purchase. So whether you purchased a product or not, right? There's only one answer, either yes or no. So that is a classification problem. You are going to classify an output, right? There's another problem which is regression. Regression is something you predict a value which is not a category, right? For example, predicting house rent, right? You have a features that you live in Noida, right? You want 2 BHK, area is this is square feet. So what will be the rent? So that is a random value, right? Based on the features, a normal numerical value, not a category. So that is what a regression problem is. I hope everyone is getting the point. Like, let me check the, okay, right? So that was a classification and regression problem. Okay, moving down to, as I told you, ML model works on the data, right? Data is the core of machine learning problem. Okay, so how ML model work? As I told you, it works around the data. Data is the core of a machine learning. It always learns through the data. Without data, machine learning is nothing, or deep learning. So data is the core of it. So right, we have to focus on data. So as long as your data is proper, right? As long as your data is proper, model is able to learn more and more based on your data, right? So let me go here. So which is what is features? Features is basically the data, right? And how you engineer it, which is it is called feature engineering. Engineering the data means making your data much more valuable to the model in order to make it learn better from your data. That is called feature engineering, right? So here, as you can see, what is a feature basically? As you can see this data, like this table, right? There are passenger ID, survived, P class, name, age, sex, park, tick, ticket, fare, cabin. So these are the features, and this is basically a Titanic data set which gives you whether a particular passenger has survived in a Titanic accident or not. As you might have heard about the tragedy of Titanic, right? So these are the features, and it is going to predict whether a particular passenger has survived that tragedy or not, right? So these are the features, right? That's your data that impact the target value, like whatever you're going to predict whether he has survived or not, it is going to impact it, right? So let's say the passenger who were like below the deck, like who are more closer to the floor of a boat, have been impacted more or initially as compared to the one who have booked their seats on top of the boats, right? The Titanic ship. So that's the trend that you have to see. So that is acknowledged by only by the data, right? So this is called feature. So what feature engineering is? Feature engineering is the pre-processing step of machine learning, which basically extract features from the data, raw data, right, in order to improve the accuracy of a model. So your data might be corrupted. For example, you get a data, and in those data there are a lot of missing values, right? There, so now that data is corrupted, you have to find a way in order to make it better for your model to learn, right? So what you will do, you first option is just try all the null values or the missing values. That's the one way to go for it. Or you fill those missing value with something, right? And what is something? Something is any value during pre-processing that you take care of. For example, if a column is age, right, and there are 10 values missing in it, you either remove all those 10 rows which don't have a value in a age column, or you simply replace those value with mean or median or mode or any other value that you think it is better, right? So that is a pre-processing step of handling the data, right? Why it is important? Better features mean flexibility, right? So if your features have, like, if your data is not corrupted, if your data is good, then your model will not be complex. It will be a simple model. It will give more accuracy to it, right? It will converges to the target variable more accurately and efficiently during training, right? Better feature means simpler models and better results, right? That's why it is important. You will be learning when you will be working in this field, or when you will be learning or gain knowledge from this field, you will learn that how data is more important for your model. It is the core of it, right? There are processes of feature engineering. I'll mention a couple, three or four. First, you have to prepare the data set, right? As I told you, handling the missing values, right? Or removing the outliers. What is outliers? Outliers is basically which is not normal according to the regular data, right? For example, you given a test, everyone scored between 40 to 60%, but only two students scored 98%. So by looking on the data, out of 100, those two are outliers, right? They are different from the regular trend of the data. So handling outliers is also a step of our data preparation. Exploratory analysis. Exploratory analysis is something to visualize your data, right? Visualization using charts, finding a trend of it, pie chart, graph, histogram, right? That's what exploratory analysis is. Benchmark is something like how accurate your model is, right? Sorry, how accurate your data is, right? That is what benchmark is. There are few methods. I'll just name imputation, as I told you. Handling the missing values, that is what imputation is, to fill some with something, to impute those values with something, right? Outliers, as I already told you, like log transform, encoding, scaling. So like log transform, encoding, all those things are like model. Your machine don't understand string, it only understand numbers, right? So if a column includes strings, let's say gender has male and female, so your system doesn't understand categories like male or female, it only understands 010101. So you have to encode them into numbers such that the model will understand, right? So that was log transform, encoding, or scaling. Scaling is something to make your data on a same scale, right? What I'm trying to say is, if you have a two columns, let's say age and a salary, right? Age, the values of age will be 20, 23, 30, 35, 40, 70, right? But the salary values will be 20,000, 30,000, 40,000. So you can see the difference in the range of values. So we try to bring all those range on a same scale by do some of the techniques like normalization, standardization. These are some of the techniques in order to make a model learn better. If the data will be on the same scale, then model will learn much faster, right? So there are a couple of libraries to go with. Just to go with, I'll suggest, let me simply open a notepad and let me write a couple of things that you need to take care of before entering into this field, and you have to be like proper get ready with these libraries. One is pandas. I'll just mention and write it down, right? I'll just mention and write it down. Pandas, this is for handling data frames. What is data frame? Data frame is basically tabular data, right? Or series is also a tabular data, but it only has a one column, right? So for handling tabular data you use pandas. I'll mention. Then you have numpy library. Numpy library is for mathematical computation, right? Then there are couple of visualizing libraries, which is, I'll write here, visualizing libraries, which is Seaborn and Matplotlib. These are the basic libraries that you have to take care of, right, in this field. So these are the four basic libraries. Pandas for handling data frame series. What I mean by handling is basically data manipulation, data extraction, data transformation. It is all done using pandas in Python. NumPy is for mathematical computation, for dealing with matrices, finding the mean, median, standard deviation, variance, right? Or high advanced mathematical operation that can be done using NumPy. For visualizing your data, you should focus on Seaborn and Matplotlib, right? All these things comes under exploratory data analysis. I'm just writing it down, like all raw, in order to make you much more understand, right? These All these four libraries comes under exploratory data analysis, just to analyze your data, right? Once you analyze it, what do you move on to? You want to data wrangling. Actually, the above things also comes under data wrangling, but in data wrangling majorly comes feature scaling. Take feature scaling, data splitting. These are some of the techniques. As I told you, feature scaling to scale the data on the same scale, right? Data splitting, like for the training part, that will be like you will cover this. It's a little bit of advanced topic, but these are some of the topics. So all these are data pre-processing steps. Then you will move on to model building. Mo- what model building includes? Basically, it you will create a model now. So here you will be using sklearn library. I'm talking about machine learning only, right? You will be using sklearn library. It has different algorithms. For example, linear regression, logistic regression, right? Decision tree, random forest, svc, right? I have named a couple of like few algorithms only. XGBoost. So these are some of the algorithms that comes under sklearn library, and it will be used for training the model, right? Once you have built your model, you are going to evaluate it. The next come is model evaluation, right? There are some of the metrics for it. What are the metrics? Like accuracy, precision, recall, AUC, area under curve, ROC, right? Confusion matrix, RMSE, which is root mean squared error, MSE, mean square error. So these are basically the metrics which are used for model evaluation, evaluating the model, like how good your model is, like how good it is going to work with real life examples. Once you evaluated a model and you are happy with your model accuracy, then you will move to model maintenance. Like, right, you will keep checking your model after a regular interval of time whether it is going to handle the data well or not. If it's not, for let's say after 6 months it is not, if it is not going to handle your data well, you are going to retrain it, right? Make it much more accurate based on your present data. So these are the basic steps. These are the, I have told you, like basically the flow chart kind of steps for machine learning. You start with exploratory data analysis, where you import your data, handle your data using pandas. Then if you want to do some computation on those data, you uses numpy. If you want to visualize it, you go with seaborn and matplotlib. Then comes data wrangling part, where you do feature scaling, right? Let me write here, feature scaling and engineering, right? I have told you the few of the techniques in feature engineering, also data splitting. Then you move on to model building. Once you've done all these steps, You move on to model building. Whatever your problem is, either it is a classification problem, regression problem, or time series data, you choose one of the algorithms. These are the few I have mentioned. There are many, right? In sklearn, sklearn is a library which is scikit-learn. The full form is scikit-learn. Then once you have built your model, you move on to model evaluation. You evaluate your model using some of the metrics that I have mentioned. And the last step is model maintenance. Like after regular interval of time, you check your model how it is performing based on your real data. And if it is not performing well, you are going to retrain it, right? If you are good with it, then you don't need to retrain if your model is performing well. So these are the steps in a machine learning pipeline. I have told you the surface level information. There's a lot deep down. I've only told you the surface level information. Is everyone clear? I know many of you will be having a doubt. So if you have any, please let me know. Are there any doubts? Please let me know. Meanwhile, I'll suggest some of the platform that you want to use or you might use in order to learn more. There's a website which is Kaggle. Kaggle is a open source website library, right? Let me write it in the chat also. Kaggle, Kaggle. I have sent as a message, right? Kaggle. Kaggle is a website for data science people, the person who want to get into the machine learning and like they want to learn more about the data, how to use it. Like, let me share my screen again and show you. I hope everyone can see Kaggle, right? This is your machine learning and data science community. So it is a platform where you will find every kind of data for practice. You can see datas. For example, you can see here Amazon Prime data set is available there. If I open this, what it includes, it basically you can see user ID, name, email address, username, date of birth, gender, location, membership star, how when it is end, right? What is the subscription plan? This is a data of Amazon Prime, right? There is a lot of data set you can look into or you can search. Average monthly surface temperature, calories burned prediction, thyroid cancer risk data set, right? If I open thyroid risk data set, it will tell you all these values like family history, radiation, iodine deficiency, smoking, obesity, and based on it, it will predict whether you will be having a thyroid cancer or not. So this is a data set that you can use in order to create a model, right? There's also section of models here. If you want to use any models, you can simply look into it. You can also do code here, right? You can create it. Discussion, competitions. If you're interested in competition, so you can register for it, right? And there are also some winning prizes if your model is the best out of all others. So Kaggle is, I'll definitely recommend Kaggle you. Kaggle, just go with the data set. Take a data set. Let's say I take this data set, right? There's also code that has been done by other people. You can look at other people code also and get knowledge, like try to gather information from their code that how they are doing it. Like you can simply click on it and open it, right? And the code will be visible to you. This is the code and this is the visualization that I told you. It is all done using Seaborn library. Let me show you. Here you can see import Seaborn as SNS. So Seaborn is used, pandas is used, numpy is used, matplotlib that I told you, it is used, sklearn I told you, scikit-learn for the algorithm part, it has been used. So all these libraries is mostly used, like 90% of the time you will be using these libraries. So okay, I'll now wrap up. And as I told you, details will be shared by Tanzea. And this is do check Kaggle website as a resource. You will be getting a lot of information from it. And yeah, over to Tanzea.
Okay, thank you, Saurabh. Okay, so I think you all have enjoyed this session. So now let me tell you about the registration. Here I am sharing the link in the comment box. So see, here I have sent you the registration link. Now let me share my screen because now we are having flat 40% off discount. So you can register now along with me so that you can avail the offer of 40% off. I have sent you the link of this website. Now here you can see this is our machine learning program, which is basically a live program. Now here you can see all those details like course feature, course description, content. You can also download the description from here. Now see, here is the price, which is 12.99. Okay, so now if you pay right now, you will get a 40% off, Now let me show you. Mm, See, you can see here. After the discount, it's only 899. Okay. So earlier it was 1299. But if you pay through UPI, you will get a discount of 400 and it will only cost you 899 if you do it right now. Well, this offer is available till 14th Feb. So if you register it before 14th Feb, you're gonna get 100 400 off. Okay, so you will get this course only at 899, which is costing you 1299. Okay, so you can register it from here. Now also, the other question which I am getting a lot about is the certificate. Okay, so see, what is about the certificate? You're gonna get the certificate on your emails for this live webinar session. Okay, but a complete certificate of the training will be only provided to you if you join the our training program. Okay, so if you register and join our training program, you will get the complete certificate of this machine learning program. Okay, for the webinar, you will get it on your emails. So now if anyone has any question, please write it in the comment box. You can register it now only. You can visit the website through the link which I have shared on the comment box. Let me share it once again if anyone wants to register it. Okay, you will get the 40% off on the UPI payments. So make sure about this. If you pay before 12 Feb, you will get 400 off. Otherwise, you have to pay the original price. Okay, Shashwat Singh, you will get your certificate, your webinar certificate on your email. Okay, don't worry about it. But for the training certificate, you have to join our program, and our program will start from 1st of March. Okay, so is there any question, anyone? Okay, Shubham Chauhan, you're most welcome. Okay, thank you, everyone. Now we'll meet in our training program. Okay, thank you. Bye.
Thank
Good
you.
night.